Okay, in this video we're going to be looking at turning points, and sometimes you're going to hear them referred to as extrema or local maximum or local minimum. And you can see on this graph I have a turning point here, here, and here. So my first question that I have was to determine the number of turning points. I have 3 of them. And approximate each of them. So this point here looks like it is the point -5, -20. This point is -3, 0. And this turning point looks like it's not quite -60, so we're going to call it -55. Since I am just approximating here just to kind of give us a general idea of what a turning point is, then I'm not really interested about this being real accurate. If you said that was -58, that's fine. Okay, now we're going to be looking at the number of turning points, and a polynomial of degree n has at most n minus 1 turning points. The directions for my first set of problems here is determine the maximum number of turning points for each of the following. And I am going to be looking at this exponent here. And my answer is going to be that exponent minus 1. So in this case, 5 minus 1, which is 4. There can be 4 turning points. And here, the maximum number of turning points is 2. Now, don't get the maximum number of zeros confused with the maximum number of turning points. If you have a function of degree n, the maximum number of real zeros is going to be n, and the maximum number of turning points is n minus 1. On this first problem, my exponent is 4, so the degree of the function is 4. The maximum number of zeros is 4, but the maximum number of turning points is 3. So let me give you a minute to finish completing the table. Okay, and there are your answers for the table. Okay, problem 4. Determine the number of distinct real zeros. So I have 0 here, here, and here. So I have 3 distinct real zeros. This 0 has a multiplicity that's even because this graph bounces off the x-axis and then goes back up. So I know that this multiplicity is at least 2. The multiplicity is even. It could be 2, 4, 6, or on. We don't know, but I do know that this multiplicity has to be an even number. Okay, the number of turning points. Here's one turning point. Here's one. And this x-intercept is also a turning point. So I have 3 turning points. And remember that the least degree of the polynomial is going to be 1 more than the number of turning points, so that's 4. Okay, problem 5. There is a 0 at -2, which is right here. Is its multiplicity odd or even? Well, the answer to that is that it is odd, and the reason I know that is because the graph goes through the x-axis. It doesn't touch it and bounce off. There is a 0 at 3. Is its multiplicity odd or even? And it is even because it bounces off. Determine the number of turning points. My turning points are here and here. There's 2 turning points. And determine the least degree of the polynomial. The least degree of the polynomial is going to be 1 more than your number of turning points, so that is 3. Okay, question 6 is to approximate the turning point located between -1 and 0. And I'm going to show you my answer here and tell you that it is a maximum. And in the next part of the video, I'm going to tell you how to get that answer. Okay, this part of the video, we are going to look at using Geogebra again. And start graphing. I come over here to the left of my screen and type y equals, and I need 7x cubed. So the 7x is easy. The cubed part can be a little tricky. Hit Shift 6 to get to that exponent key. It's kind of hard to see, but I do have my cursor up here, and it's flashing in the position that the exponent needs to be in, which is 3, and my cursor is still up there where the exponent is. So use your arrow key to scroll over toward the right and then finish typing up your problem. Okay, now to find the coordinates of my maximum point up here, there's a couple of different ways to do it. One way is just to click on that point, and it's going to tell you the coordinates, and it's going to tell you that it's one of the extrema points. Another way to figure out the coordinates is over here on the left of your screen. Click these 3 little dots and click special points, and you can see all of my special points. I have my zeros labeled, the maximum, the minimum, and my y-intercept.